Good day, everybody. I trust we are all doing great. So, in today's lesson, we'll be looking at what we refer to as constructs. Okay, constructs. We want to look at constructs. Constructs, very important to look at. Constructs. Constructs. So when we talk about constructs, it's a compound word that has to do with control plus structure. Okay, that's control and structure. So these two, con and struct, form constructs. Okay, and control structure generally refers to how our program is being structured, how our thought of process is being structured. And there are three types of control structure. The first one is what we refer to as the sequential. Okay, sequential. Then the next is selection. Then of course the last but not the least is repetition. Okay, now this can also be referred to as iteration. Okay, iteration. Right, now for the sequential construct, it's one that proceeds in a sequential manner from start to finish. So it starts the execution, proceeds to statement 1, execute statement 3, and down to the end term before it terminates. Usually there are no logical statements or logical conditions that characterizes the sequential flow. Okay, so just like the sequential moves in a straight line manner, whereby point A it completes, proceed to point B, proceed to point C, D, E, F, G, and it continues on and on. Okay, now let's proceed to our selection. Now, the selection is one that based on the so now the question is this. For example, let's say I have two friends. Okay, let's say, and we have, let's say we have Adams, and let's say we have okay, and Tony. Right, now Adams is 10 years old while Anthony is 11. Okay, now and we know that this points to what? This has to do with what? Age. Okay, so we can have a decision that based on the age, okay, that based on the age, let's move. That based on the age, yes, based on the age, that based on the age, okay, that based on the age, that based on the age, okay, so now based on the decisions, we may have it this way, okay, we have it this way. So just to buttress the selection process, so what the selection does is this. So have it this way, okay. So we will now have that if age is greater than um, 10, okay, if it is true, now if it is true, of course, or you can say yes, then false or no, okay. And you know, based on, you can decide this true can either be at this point, okay, or the false be at this point. It can either be at any of the sites, okay, and you can use either one that you so wish to in terms of the Boolean outcome. So when you talk about the Boolean um, the Boolean terms, or the Boolean terms, or better still, Boolean variables, okay. They are just of two types. Variables is just 0, 1. This we say is what? False, true, or you might want to say this one no, then this is yes, okay. So that is the Boolean variables for us, okay. Now so now it is false here. So if based on the imputed age, okay, based on the imputed age, if the age that was imputed, say is 10, okay, or if you impute, so let's make it much more the condition here. Let's say age is let's have it that age is equal to 10, okay. Now if we have this condition, okay, then it now holds that if we impute an age, it will come and check is age, right, is age, if you check, is age equal to 10, is age equal to 10, so and we have imputed 10. So if we have 10 here, of course 10 is equal to 10, right? That's true. Then it will display that what? It should display Adams. Okay, it has identified Adams. Then of course, if this ceases to be 10 and it's now 11, okay, 11, of course, 11 is not it is false that 11 is equals to 10. So it will come here and display what? Antony. Alright, so it makes Antony. It will display Antony. So this is going to be what? Antony. Can you see? This is going to be Antony. So this is Antony, and this is what? Adams. Antony, Adams. Antony, Adams. Okay, this is Antony, and this is what? This is Adams. So basically, that is how the selection process goes. And this decision is usually more than one. It can be multiple decisions based on the problem at hand, right? So that is about the selection. Now let's proceed to repetition now. Now the repetition enables us, it gives a condition whereby there is a continual process until a set of criteria is met, for that process to stop. Okay, from in going, you say, for a process to break, to come to a halt. Now take for example, right? Take for example, I have a sequence of numbers. Now if I have a sequence of numbers, say that number should be defined by what? N. Say the number is defined by N, and the sequence of number is 1, 2, 3, 4 to 5, right? And then we want to get the sum of these numbers. Is that clear? Now definitely, how to do this is that you now see that for us to be able, that's going to be 1 plus 2 plus 3, and that's going to be 6, 10, 15. So we have that sum, the total sum. We need to have an idea that everything sum, our sum is going to be what? 15. When we add everything together, we get what? We get 15, right? But what we are now cautious about is how do we go about this, to develop an algorithm that will be able to proceed to compute this. Now, so let's see how that can be done, right? Now, demarcate this out. So now, for us to be able to proceed with this, we'll still have a quick let's have if I have my set of conditions here, so then of course we have this, then of course we have a process here, okay, then okay, then set of, then of course so okay, so then of course this terminating side, so terminating side, good, okay. Right, so I guess we have this. So now we want want to sum this, but you know there's always an increment of, if we add plus 1 to 1, it gives us 2, plus 1 3, plus 1 4, plus 1 5, then plus 1. Of course, you see, if we add plus 1 to this 5, we get what? We get 6. But 6 in this case is what? An outlier. Okay, an outlier. We really don't need is an outlier. Okay, so this is set of condition that we are going to consider right now. But we can also pay attention to 5 depending on your preference of or your condition. So over here now we can say is right, is the condition is on n, is n, okay, is n less than or equal to 5. Now look at this. 1 is less than 5, 2 is less than 5, 3 is less than 5, 4 is less than 5. 5 is not less than 5, but 5 is equal to 5. So which means by the time we get to 5 is equals to 5, then of course by the time we get to 6, 6 is not less than 5, and 6 also is not equal to 5, then the loop will break on what? On 6. Okay, that's if you want to use the condition 5. But however, if you do not wish to use the condition 5 and you want, let's say we want to stick to the condition 6, now this is what happens. 1 is less than 6, 2 is less than 6, 3 is less than 6, 4 is less than 6, 5 is less than 6, but 6 is not less than 6. So there's going to be a breakage on the loop. So depending on what situation you want to consider, you can use less equals to 5 or just strictly less than what? 6. Now let's proceed. So of course we have a question mark here. Now this question mark is just for a null. Whether you put it or you don't put it, it really doesn't affect your flow of thought. It doesn't affect your algorithm. Okay, so now what you now want to consider now is this. Now we need to have a starting value for n. And what is the starting value of n? The starting value of n is what? N starts at 1, and we also need to get sum. So our initial sum will be what? 0, because whatever you add to 0 will be that same number. Okay, right. If we were considering product, then this product would have been a what? A 1. We say that our product is what? Is 1. Okay, but we are just strictly considering sum in this instance, just to explain our repetition construct. Okay, so now the next thing is this. We will proceed and have this as sum. Remember, we want to sum. This is going to be sum plus the value of n. Then of course we'll come and update the value of n with 1. Is that clear? Now by the time we have this, then our process, let's begin our process. Let's assume that n begins from what? From 1. Okay, and you've imputed n. So if n is imputed as what? N1, then of course n is going to be what? 1. We now ask, is it true that n1 is less than? So of course this is going to be what? Yes. Okay, and then at this point is going to be what? No. Right? Okay, you may say, but why am I always clicking on the right? It's just my preference. I always like to say yes to go to the right hand side, but you may prefer your yes to go to your what? To the left hand side, meaning that all this loop now, okay, all this loop. Why did I say loop? Because your repetition forms what you call a loop or looping. Okay, loop. If you check this is a loop. If you check the loop, it just means something that has been encircled. Okay, if you check, this is a loop. There is a loop here. It's an enclosure. You can see it. There is no space, no going out. It keeps looping around until a set of conditions met before it will now what? Break out. Okay, so this is, we have a loop here. Okay, your process is a loop. Now, so our sum, don't forget, our sum is 0 and our n is 1. So 0 1, our new sum will be what? 1, right? then our n, which is 1, will now be updated to what? 1 plus 1 now will be 2. Do you see? Then what is coming out for the value of n now? That's going to be what? 2. So 2 will come here. Is 2 less than 6? Yes. Our n now becomes what? 2. But don't forget, our sum was what? 1. So this will become 1. 1 plus 2, this becomes what? 3. Alright? But don't forget, n now is now 2. Then this is going to be 3. Then this will be updated to 3. Okay? Then, of course, this is 3. And then this is another 3 here. Okay? So this will be updated to 6. Okay? This is 3. Then this is going to be updated to 4. Then, of course, 4 will now be here. 4 is less. Then this will now be 4. Then this will be 6. Then, of course, this is now be what? 10. Do you see? Then, of course, 4 will be here. And then this will be updated to what? To 5. Then, of course, this will be updated to 5. Then 5 is 5 less? Yes, 5 is less. Then, of course, we have this as 5. And then this as 10. Then this is going to be what? 15 now. You see? This is 15. Okay? This is just for the purpose of emphasis. But usually you don't write on your algorithm. Okay? In subsequent videos, I'm going to show us how to develop a dry running table for you to determine the output of your algorithm. Okay, so at this point we have 15, but you know n is 5, so n here is going to be 6. So by the time it gets to this place as 6, the question is 6 less than 6? Then definitely it is what? No. Then it will come here. Our sum is now what? 15. So it will say display sum. So at this point, sum will be displayed and the result of sum will be what? 15. Just like we have said here, it will be 15. And then the whole process will come to a what? Don't mind me. This is actually just to explain this algorithm. This is not a full-fledged algorithm, okay? But subsequent videos, we will give a full example of this. Then, of course, before you now come to a what? Before you come to a stoppage, right? So basically, this is how the repetition loop actually, or the repetition construct actually works out. So we have this as our selection, okay, and then this is sequence. Now it may interest us to know when we are writing a program, what commands usually do we use in bringing about selection and repetition? So when you are writing a program in your code, okay, we use commands like if, we use if else statement. Like in Python is going to be what? An if, okay, depending on your language. So this if else. Then third, we use the switch command. Then of course we have the conditional statement. Okay, conditional statement. Then for our repetition, we have the while, then we have the for, then of course we have the do while, then some languages they have what you call for each. Now this for each is just a command that helps the effective manipulation of your arrays and your list directly. Okay, it's much more efficient than this as for each. But however, these three proves very they are the most important commands when it comes to your repetition. So this is very important because when selection comes to your mind, okay, you are likely not to make use of while or for. Okay, however, it is important to also state that this command, depending on the situation, it can be used together. There is what we refer to as what? Nesting. That is, like, it's just like you have a basket now and then you are placing a cup. in a basket. In programming, that bigger basket and that smaller cup, when you place the cup in the basket, we call it what? Nesting. When you place a function in another function, okay, or a command in a command, we call it what? Nesting, right? So at this point, we have successfully looked at what control structure is, and we have looked at the three types of um, control structure. We said we have the sequential, we have selection, and we have repetition, and we have been able to give this detailed example about how, how repetition works and how selection also works. So I wish us a let's have a wonderful day, and God bless you all.